much blinking into to tell me it's alright.
Hello. Hello, everyone. Hey, thank you so much for coming to our office. Really appreciate everyone coming. Warmers welcome. Please help yourself to food and drinks and everything here in the office. I'm Jeff, one of the directors of engineering here at Faire, and wanted to welcome you all. So first thing is office housekeeping. So please ensure you keep your visitor tag on while you're here. It helps us like identify who's an employee versus who's a guest. Washrooms are located right behind me here, just down on the wall on the left. And please remain in this lower level. The office is pretty big. You can get a tour if you have a chaperone, but please stay in this level while you're here. So first up, like, thanks for coming today. If you're not familiar with Faire and who Faire is, we are a wholesale marketplace which helps small businesses find the best products to stock in their stores. We have over 1 million retail shops and 200,000 brands across the world. We were founded in 2017 by 4 former Square employees. Tuan Pham is our CTO. He's ex Uber CTO. He was at Uber for 7 years and went through a lot of scaling of infrastructure during that time. And we've raised over $1 billion in venture from top VCs, including Sequoia, over our years. Okay, our engineering team. I want to talk to you about our engineering team. We have 300 plus product, infrastructure, data engineers based out of Toronto, KW in Waterloo, San Francisco, and remote. You're probably meeting some of them tonight. Please feel free to just come up and talk to us after the talk as well. We're working on really hard technical problems, which is why the talk is called Scaling for Growth. We're trying to scale a lot of our systems and processes and tools that you'll hear about today. And then the recruiting team made sure I added this point, which is we are hiring. You can go to faire.com/careers and see some of our openings, and if any of those take your interest. Let me talk about the agenda today. So we've got a bunch of cool talks ahead of us. We're going to talk about how we're scaling our front-end infrastructure. Michael and Chris are going to go through that. Our site performance, Hamid Reza will talk about that. How we scale our internal tooling. Jordan and Alir will give some really cool stuff there. And then how we scale, how we build features. That will be How and Philip. So excited to kick this off. First up, Michael. Here you go.
Hi, everyone. I'm Michael, and I'm a senior front-end developer on the web platform team at Faire, and I'll be talking about how we've scaled our front-end code bases and our code architecture as our number of code bases and their sizes have grown. So first, let's take a look at how things used to be organized. In the diagram, each box represents a repo, but the number of boxes is not exhaustive. In reality, there's about 20 repos. And at the top, we had a couple monolithic libraries that were used by everything, even each other. And then next we had our production React apps that were served to our customers. And then on top of that, we had even more internal React app repositories. And then lastly, we had miscellaneous TypeScript tooling repos. This included anything from a Chrome extension, a CLI, node services, and much more. And that's how things were until the end of 2022, when we decided to make a change after a number of problems had slowly grown over the years. So let's take a look at them. Our first problem was that at Faire, we tried to keep a unified stack, which as a result meant that dependency upgrades required a PR per repo. And with 20 repos, that was a lot of overhead to do. And so we were starting to see a number of repos fall behind due to the overhead to upgrade all of them. And then this increased the friction to work in those repositories and wasted developer time. Our next problem was that every project had its own configs for tools like Webpack, ESLint, and more. And over time, these configs drifted, making the developer experience across repos and apps subtly different. This increased the maintenance burden and increased complexity of CI and our release process. Fixing these problems was also a complex task because of the effort needed to re-architect. Changes would need to be pulled out into a shared library and then updated across repos. Because of this high overhead, it historically has not always been done. And still, over the years, these libraries grew to become very monolithic and intertwined in strange ways. And creating a new library to break out some of that functionality involved even more overhead, such that it was practically never done. And then when you made changes to these libraries, testing code also proved to be difficult. It was not easy to fully test the integration of shared libraries with all downstream projects, resulting in frequent breakages that hindered our developer productivity. And so to resolve these problems, we decided that a monorepo was the path forward. To manage the monorepo, we've adopted the NX build system in conjunction with Yarn to manage our dependencies. And let's take a look at how the monorepo solves each of our problems. First, with atomic commits, dependencies can be upgraded in as little as 1 PR across all of our projects and all of our apps. This significantly reduces the overhead to keep things up to date. And then next, we leverage NX executors, which provide abstractions on top of tools to enforce standardization and preventing configuration drift across different projects and apps. Then we also use NX generators, which automate bootstrapping and reorganizing projects, which significantly reduces the complexity to re-architect. And lastly, the NX project graph ensures that all downstream code affected by a change is properly tested before it can merge, allowing it to integrate seamlessly. And so what have we learned here? Well, over the course of our journey so far, we've learned that a monorepo is not our end goal. It's only the first step towards drastically improving our front-end code architecture. Something that we've learned the hard way is that any existing pain points in the development process will be magnified by moving to a monorepo. Your node modules folder will grow to an ungodly size. CI will get slower, bad commits and flaky tests will block the entire repo from deploying, and the IDE performance will degrade, among many other things. We've accepted the challenge and have designed parts of our infrastructure to scale alongside with the monorepo. And let's take a look at some examples. We've landed many improvements to how we handle our ever-growing number of dependencies. The upgrade to Yarn 4 reduced our install times by 4 minutes. Generating minimal package.jsons to use in Docker reduced our image build times from 15 minutes all the way down to 2 minutes. And using a node module cache in CI reduced our load on our self-hosted registry. And next, the monorepo is also accelerating our adoption of Playwright to have faster and more reliable EDE tests through shared infrastructure across projects. And lastly, we're enabling teams to improve their productivity with tooling to easily split up large apps into micro front ends. And speaking of large apps, I'll pass the mic to Chris to talk about our largest app and its migration to Next.js. Thanks.
Awesome. Thanks so much, Michael. Hey folks, my name is Chris. I'm also a senior front-end engineer at Faire. Today I'm going to talk about our web architecture journey to Next.js, which is a popular React framework, if you haven't heard of it. So when our co-founders were building Faire back in 2017, they decided to build it with React. Our setup was exactly what you'd expect from a vanilla React app at the time. The only key difference was that our Kotlin backend would dynamically serve the initial HTML document. But then everything else was exactly, what you'd expect. This approach meant that browsers would need to sequentially load the HTML document, then fetch the JavaScript, then execute React, which might go back to the server to fetch more data, and then eventually render the page and download images. All the while, the user would see nothing, just like an empty page until React was done rendering, which is pretty slow. So we decided that we wanted to take advantage of server-side rendering so that the initial HTML document that we sent down to browsers would be rich and that the user would be able to see meaningful content immediately as soon as they got a response. But to server-side render React, we needed a Node.js server, and our backend stack was written in Kotlin. So we spent many years building out our middleware in Kotlin, like authentication, rate limiting, and we didn't want to rewrite all of that in TypeScript. So the simplest path forward for us was to leave the request flow in place and add a Node.js server that our monolith could call out to render React pages. And that's what we did. And we did experience some wins. We dropped our LTP by up to 50% on some of the pages that we enabled SSR for, but it wasn't quite time to celebrate just yet. The SSR phase added around 100 milliseconds of latency to the initial HTML request, and it only sped up direct loads and not subsequent navigations. So, and also, as our site began to scale over the years, it became really difficult to keep our core JavaScript bundle size low, even with code splitting and other optimizations. So SSR was not a silver bullet to performance. Also, our SSR implementation was in-house and prone to memory leaks, and was difficult to enable across the board because of hydration errors. So we decided to cut our losses and make an even bigger bet. So I'm borrowing the slide from React Conf this year. It's Ryan Florence's slide about essentially he was talking about large companies with big React apps having this meeting to modernize their tech stacks. And it's kind of funny because we had this exact same meeting last summer. Yeah, so we knew we wanted to use a React framework, but we had a tough decision to make. Because our React apps were built with React Router, Remix seemed like the obvious choice, since they're actually merging soon into the same React framework, which is going to be called React Router v7. But Next.js, on the other hand, had really close collaboration with the React team and implements features that make up their full stack vision, like server components, streaming, and server actions. There were also many large companies that were already using Next.js, which is another really positive signal. Also, because we were struggling to get a hold on our bundle size, we were really keen on moving more of our JavaScript to the server only using server components. So we picked Next.js. But the migration path wasn't easy. There were many problems that we needed to solve, too many to fit into one short talk, but I'm going to highlight the top 3 that we championed along the way. The first one was routing. When we decided to use Next.js, we needed a way to synchronize the Next router with React router. And we did this by writing our own compatibility layer between the two. There were many bugs in the early days, but we were able to iron out most of the kinks before launch. Second was getting Next.js in front of our application services. Because we didn't want to rewrite all of our middleware in TypeScript, we extracted it to a thin proxy service. That way, Next.js can fetch data from other services without creating cycles in the request flow. Third was localization. So at Faire, we localize our client code by creating chunks for each locale at build time. To support this in Next.js, we actually had to create a thin wrapper using an Express server that transforms the response stream to include the locale in the document and RSC payloads. And the impact was huge. We got faster time to first byte because of streaming, faster FCP because of Next.js's smart bundler, and less abandonment on our logged out pages that adopted server components. And we also had many learnings along the way. One of the big ones was that we probably should have followed the React community early on and adopted a framework rather than trying to implement our own. Another one was that while this was a massive undertaking, we really just needed to decompose the problem and start executing. There are a lot of unknowns and mistakes that we made along the way, but we just needed to break things down in order to make a ton of progress. And the last one was that Faire has some really awesome engineers. There are many technical problems to solve along the way, which were great opportunities to grow alongside some extremely talented individuals. Feel free to check out the full blog post on this. It's on thecraft.com. And up next, we have Hamid Reza, who's going to talk about speed. Thank you.
Good evening, everyone. My name is Hamid Reza. I'm also a senior front-end engineer here at Faire. Today, I'm going to dive into how did we scale our website performance. Yeah, over past few years, we have been incredibly productive, shipping numerous features at rapid pace. With this aggressive development, we soon understood that it might have negative impact on our website performance and our customer experience. So slow build times can lead to frustration, abandonment, ultimately turning user away from our website, as we heard from our customers. So also this presents us with a significant opportunity to make positive impact. There is a blog post from Jeff Atwood that with the title "Performance is a feature," and you can read that blog post, and it's a recommended read. At Faire, we have documented that it has the performance has a direct impact on our business outcomes. Through our numerous experiments, we have established a correlation between decreasing 100 milliseconds in our latency on some of our CUJs or critical user journeys, that it can lead to 1% of GMV, which we call it global merchandise value. And the opposite is also true. If you regress the latency for 100 milliseconds, you're going to lose 1% in business. So for us, it's not a technical problem to solve. It's a strategic advantage for business. So this is one example on logged in homepage. And I put this screenshot here because most of you never saw it, because it's for our logged in retailers. We see that we reduce the homepage latency from 25 seconds, it's P95, to very more acceptable 8.7 seconds. And we did it through like 7 experiments, and we banked over 3% of GMV, which is correlates to business improvements. And next, to effectively measure and improve our website performance, we need a metric that would provide a comprehensive and accurate assessment. Our goal was to define a metric that has like the following criteria: consistent method, measuring loading time across different pages and devices, a measurement that captures performance dynamic even when the user navigate within a single page application, the ability to break down the loading time into specific segments and like image download time or data segments, a metric that indicates when the page is fully interactive and usable by the users, and in short, a metric that aligns how user actually perceive the page load speed. So as a result, we created a synthetic metric. We call it user perceived load time, or UPLT, which is kind of a buzzword around here at Faire. And you're hearing it now. So if you decide to join, you have a start. UPLT, or user perceived load time, is a unique metric to capture the actual moment that the page becomes not just visible to the users, but also usable for the end user. This flowchart shows the all the steps and stages that we have implemented to measure this accurately. But for engineers, they don't have to like go through all the hoops, and it's all implemented and instrumented throughout our code base, and it's just really easy to use. So the next step is like, how did we just improve the performance? We did lots of experiments, and we did use lots of techniques. I'm just describing a bunch of them here, but it's not all. The first one would be like the bundle size improvements. So we soon understood our bundle size is big, and we did lots of analysis and reduced the amount of assets that users don't have to download at first, or they can lazily download those assets. So downloading less data upon visiting the website would just improve the page load time speed. The next one would be laser rendering on the clients. So this one will delay the rendering of non-essential elements on the page, and this will reduce initial load time, and also allowing the users to interact with the critical part of the page much sooner. The other one would be the data and chunks per fetching. We anticipate that the users might need some data in near future, or might visit some page in near future, and we do prefetching of the data or the chunk for the next page, so they can have much faster load speed time for the next page. Also, we did a lot of backend API latency improvements. I'm a front-end engineer. I don't know much of them, but they did a lot behind the scene. But as you know, the faster API latency time would greatly reduce the perceived load time for the users. The other part would be image optimizations. We use new image formats. We used the browser, responsive capabilities to show users image with higher qualities, with lower, size to improve the speed. Also, as Chris mentioned, we employed server-side rendering, which reduced initial load time abandonment a lot. And also, we are actively using React Server Components, which is very new to the community, and we are actively using it on production, which is great. Also, the other part, which is really important, all these speed gains that we could achieve, we need to maintain it. In order to maintain the website performance, we employed, when we are implementing a new feature, we pay special attention to the website performance. Every new feature that going out needs to be analyzed for the performance and make sure it wouldn't affect the website performance negatively. Also, when we are running an experiment, we created many metrics that will measure the website performance between the control user and treatment user. As you can see, this is one screenshot from our experiment lab that, for example, for navigating to homepage, this experiment reduced the average latency by 10%, and we have some goals for performance that it improved the percentage within the goal by X number of percent. Also, we have surface level latency monitoring. So if on a surface level we see a regression, for example, on search page, we see a regression, respective team will get a notification that we detected a regression on this product area, and they will go investigate what would be the cause of regression. So through all these steps, we will make sure we wouldn't regress the website performance, and we will monitor everything daily. As you know, our commitment to performance had like a significant result. So over the course of like past 2 years, we ran over 160 experiments across front-end, back-end, and our apps, with mainly focus on speed. And on our critical user journeys, we improved the website performance by over 60%. And through all those, speed improvement, we also banked over 60% of GMV, which is again global merchandise value, which correlates to how our business would grow. And as we innovate and grow, performance will remain a cornerstone of our strategy, ensuring that the seamless and enjoyable experience for our customers. Next, we have Jordan talking about internal tooling.
Hey everyone, hope everybody's night is going well. I talk very loudly, so I apologize if I deafen you by speaking too close to the mic. But yeah, I'm Jordan. I am also a front-end engineer here at Faire, yet another one, but I will be talking about something that's not necessarily the front end. I work on our web platform team. I have historically worked on a lot of internal tools that we use here at Faire, and so today I'm going to be covering the evolution of one of our most used and most important tools, and it's something that we call Faire. Obviously, we're very punny here at Faire. So I'm going to take you back to 2019. This is 2 years before I even joined Faire. We had two very simple problems that we wanted to solve. So we wanted GitHub notifications in Slack, and we wanted the ability to automatically merge PRs when all of their checks went green. Now, you might think these are obvious problems. However, they've not been fixed. They have. GitHub has since implemented these, but at the time they were not. So we created Faire, or what we called it internally was PR bot. It's pretty self-explanatory. It's a bot that deals with PRs. And we built that around 2019. So very simple, there we go. Very simple solution. It's a Node.js service that receives webhooks from GitHub, has some business logic to determine what we actually do with those webhooks. And so it determines, if some conditions are met, it might post a notification to Slack, letting people know that maybe their PR has been merged. And if all required checks are on the PR and it is labeled auto merge, we'll merge the pull request. It's pretty simple. This is kind of all it did in its inception. But now that we had a Node.js service that was integrated with GitHub and Slack, what else could we do with it? We started looking for opportunities to simplify processes and give developers information faster to save them time. So some of Faire's feature set was planned via a few members on the web platform team, but a large portion of its features were requests from other members of the organization just wanting specific integrations. It quickly became apparent that teams wanted to take advantage of the service. We instantly started getting requests to implement things like automatic review assignment, review requirements, custom notifications. In this scenario up here, we're notifying somebody that their changes were published in a particular package. And also some attempts at reducing some review time by poking required reviewers when their review was past SLA. So they were just maybe slacking on their reviews a little bit. The problem with this is our org 4 years ago was very different than it is today. So today we have over 35 teams across engineering and data with developer functions distributed amongst those teams. That's the graph on the left here, and each bar represents like the back-end, front-end, mobile. And we have a code base that has expanded a lot. So catering to every team's needs was not scalable, considering Faire was just one of the many tools that the web platform team owned. So what did we do with this? We implemented a self-serve model to allow teams to and individuals to configure Faire's various integrations. So they could configure how they wanted to receive notifications, who they should require review on their code, if we should leave any additional comments on PRs, letting people know more information that they might want to have. And they could also customize auto merge behavior. Some of these examples here, it might be a bit hard to see, but one of them is a comment on PRs letting people know that they skipped a particular check, and in doing so, they might have introduced a backwards incompatible change. We also have a configuration here that notifies a team's channel when a specific important file they own is changed. Let's just say you're changing like the core cart service and they want to know that somebody's touching it. So to build this out, we had to define a well-typed configuration system. Since our service was Node.js, we built our configuration types in TypeScript. This is why it was built by the web platform team and not the backend platform team. And it allowed us to easily read configuration throughout the code because we had the types available to us. We mapped these types to a YAML schema because we found it easier for folks to configure via a YAML file versus doing something like JSON or some other method. As we added new capabilities to Faire's integrations with GitHub and other services, we could just update these types. It would update the available schema in YAML, and then people could go in and use this well-typed system to configure the system however they wanted. In these two examples here, one of them is someone's configuring an automatic review, I think, in one specific repo when they touch any of the cart file paths. So maybe you want a review from the cart team, as an example. And another one, this is a check that is designed to always fail if somebody touches a particular file in or a particular folder in our backend repo, because that folder has been deprecated and we don't want anybody touching it. So it's going to automatically fail your PR. So today, the configuration looks something around 70 review assignment configurations. We have around 90 custom PR requirements. Don't worry, this is not 90 requirements on every single PR. It's distributed based on which files you touch. We have 40 custom notifications, and then in total, the configuration is over 5,000 lines. And this does not include other integrations or functionality that we've built into the service ourselves. This is just what's configured by everybody else at Faire. So to give you some idea of kind of like how frequently Faire is used, these are some metrics that we've collected from the past month. So we've had over 18,500 automated Slack messages. This includes integrations that get sent to like Slack channels, such as like alerts or deploy notifications. Don't worry, we're not spamming like every developer with 18,000 DMs. And Faire has also performed around 7,400 auto merges, and we have assigned around 2,000 reviewers automatically to PRs. So, you know, folks don't have to go looking for who should they assign to their PR. And it's also performed many more actions that you can kind of see below, and then the list kind of just keeps going. So this is kind of what it looks like now. We've expanded the tool. Faire looks something around 9 services that it integrates with. We've added integrations with Datadog, Jira, Workday, Notion, Zendesk, as well as like a handful of internal tools that we've built. And it's become kind of the central point of integration for all of these services. Now that it has access to kind of all of this information, we kind of thought to ourselves, how can we give it superpowers? What can we do with all of this information? And in 2023, this thing called LLMs came along that people might be familiar with. And obviously, like every other company, we started investigating ways that we could use them. And so we looked at how can we use LLMs to up-level our existing integrations. I won't go into too many details about this because that could be a talk completely on its own. And in fact, we do have a nicely written up post about how Faire integrates with LLMs on our Craft blog that you can go look at. But in a nutshell, a request comes in, whether that is from an employee specifically talking to the bot itself in Slack, or from one of the many integrations that we have. It processes the request, determines the appropriate LLM assistant that should be applied to it. It then triggers the LLM assistant with the prompt, and the assistant can then make function calls back to Faire for any of the information that it might need. So if a function call needs to get who a person's manager is, Faire can then go reach out to Workday and get that information for you. I will go over one specific example of this because there's just kind of too many of them and we don't have time for that. So this is one that we call our test coverage assistant. What happens in this assistant is we receive a webhook from GitHub, which is what Faire was already doing. We then decide that we want to apply an automated LLM review of the pull request. And so what we can do is we can call OpenAI with our pre-configured review assistant. The assistant then uses function calls to get all of the information that it needs to actually perform the review. The review is then returned back to Faire, and then Faire posts that review back to GitHub, telling somebody, hey, something went wrong. For the test coverage one, it also actually fetches extra metadata. So it actually grabs the coverage report for the pull request. And then, if the report has failed, it can then create suggestions on how to get the report passing. I'll showcase this working in the next slide. So this is kind of what happens. This is a comment that we've left on there. It says that this PR is failing our test coverage checks, and you've touched this PR, and it asks you to please add tests, and it adds some suggestions. It says, here's the file that you want to change. This even gives you the file path. It generates the test file code, so you can just copy and paste it. It does some stuff where it mocks it. It creates the test suite. It has individual tests in here. And then after this is all done, it will actually go and explain kind of what each of the test cases does so that you know what you're looking at. Obviously, we don't expect developers to take this and just copy paste it directly into their code. It's just a good starting point for them to write tests. So it gives them less of a reason to bypass the test coverage checks and merge code in. And so that's kind of how we use Faire here at Faire. And I'm going to pass it off to Alier to talk about Builder.
Hey everyone, I'm Lear. I'm the fifth and last senior front-end engineer that you're gonna hear today. So before we talk about what is Builder, let's first talk about the problems we faced. So for our marketing team, they would like to have different landing pages for their campaigns, trade shows, ads, and etc. However, creating a landing page requires a lot of engineering effort. And to make things worse, it can take us 3 to 4 weeks to collaborate and code the landing page. So this is a significant bottleneck in our workflow. Ideally, we like to empower our marketing team to be able to create their landing page on their own, so they don't need to be dependent on engineers. And after comparing several solutions, including building it in-house, we chose Builder.io, which is a headless CMS with a visual editor. You can see it has like a Figma-like UI, which is very easy to use. And even if you cannot tell HTML from CSS, you can still create beautiful UI components with it. And here in the strip, you can see Builder working action, and it is going to change an image and update header. So yeah, very intuitive to use. Builder was our best choice because we can ship faster, cheaper, and better with it. Because of its intuitive codeless UI and the ability of publishing changes instantly, we can skip some of the most time-consuming steps when shipping a product, which is one of our biggest bottlenecks to ship fast. And as a front engineer, to be honest, I don't think creating static UI components is very challenging or exciting. And Builder can reduce that engine dependency and frees us from these less challenging work. And it also limits the cost of CI. and also ships better because product iteration is important to make sure we deliver the best experience for our customers. And it could be as simple as a text, layout, or style change. But today, the most harmless one-liners still need to go through the whole CI/CD process to reach customers. But Builder can get these improvements out as soon as possible. So it sounds very simple. We just use a third-party website and let marketing to use it. What's so difficult about it? Well, I wish it was that simple. One of the catch here is because they're not engineers, they don't have the web development experience as us. And it could be risky because there's no test. It goes to production instantly. And it's kind of scary to think anyone who has access to Builder will be able to skip all tests and change our main site in production. But what if I told you you could have both speed and quality and safety? So let's dive into all the measurements and guardrails we've set to ensure quality. To maintain consistency, we developed a script to register our design system within Builder. And we've also created reusable UI templates inside Builder for the marketing to use. They can just simply drag and drop templates and update the content as needed. And we've also implemented access control to ensure only authorized users can publish changes. Plus, we set up a development environment in Builder to prevent accidental changes from affecting our production. And to keep everything running smoothly, we added alerts and monitoring. When changes go live, Jordan's PR bot, the Faire, will send us a notification on Slack. We've also built dashboards to monitor performance. So we did a bunch of stuff to make Builder easy to use and difficult to make mistakes. And we try to make the process as smooth as possible. So we automate a lot of our workflow. And there's just one example that we did, which is to let Faire notify us when a change has been published in Builder. So what we did is we have a webhook that listens for Builder changes. And after we get the updates, we'll parse the updates and let PR bot Faire notify Slack. So we use this trick for other things as well, such as our localization process. It is much more complicated than that, but before this process, our marketing team had to add translations into Builder manually. So let's say if you have one string on the website, they need to do it for like 20 times for each locale. But with this process, they only need to add the content in English, and everything else is handled automatically. So you can see the setup is pretty similar to the Slack notification one, where we also have a webhook listens for Builder changes. And then we extract the content and send them to translation service for translation. And after we get back the translations, we'll push back the new content with translations to Builder. Okay, so after all this work, what have we accomplished? Well, now the marketing team can create, implement, and launch a landing page all by themselves without any engineering effort. We estimate that for each landing page, there's a 75% saving in engineering weeks. That's from 4 weeks to 1 week per page. And so far, we've launched 10 pages, which means we have saved 30 weeks of engineering time. And on the right side, this is an example of a landing page that we just recently launched. So yeah, it has like a lot of elements there, and it also has a form embedded, FAQ, and everything. And we're not stopping here. If the marketing team can create a whole page themselves, they can definitely create things like banners or models. So we're going to look for expand our usage next year. And another main feature that we're currently working on is empowering them to launch A/B tests directly in Builder. This will allow them to experiment and optimize content without needing to wait on engineers. Thank you, and I'll pass to Hal and Philip.
Hey earlier. Yeah, welcome to our chat about the how we build features at scale at Faire. Next slide. I'm your lone backend engineer here at the stage. Philip.
My name is Hal. I'm also not a front-end developer. I work with our mobile team on iOS.
Okay, so we want to introduce a new pattern we use for scalable developing. It's called server-driven UI or SDUI. So what is SDUI? SDUI is an architectural pattern that allowing the server to specify the UI rendering details. Let's say we have a website building web, iOS, and Android. In the legacy architecture, the server only cares about like providing the data pieces, and the clients handles the data rendering based on those data. And the implementation are different due to like different clients using different framework, and also like obviously different programming languages. But after some coordination, we managed to keep things in sync across different clients. Things start to get a little bit complicated when we start to serialize more and more data to clients trying to display more complicated UI due to, of course, we want to personalize our user experience for each user. While more business logic start to exist on the clients, the implementation start to get diverged. And we need to spend more time to write automated tests just to make sure things are in line. Then we start to use SDUI, where all this complicated business logic are evaluated at the server side, and no more fights from the client side and the PC switch. This is basically SDUI in a nutshell. For all of your like a client engineer, if you want to be bugged less by the PM and let PM bug backend engineer like me, join Faire. There are so many reasons to adopt SDUI, and I would like to highlight some key benefits from the engineering perspective. First, instead of having all the business logic and the rendering logic scattered across the different like client-side code bases, SDUI consolidates them on the backend. This ensures consistency across the code bases, as it eliminates bugs like different clients having different wording or image like displayed. It also reduces the code complexity on the client side by moving all the business logic to the server side. Additionally, rather than requiring client engineer to update their respective code base for any UI changes, we can now centralize the and manage those updates on the backend, which significantly reduce the effort that required here. It sometimes, at last, it sometimes can take up a couple of months for most of the user to update their mobile app version to the up-to-date one that carries a new feature. With SDUI, we don't need to wait for that, and with the one like backend changes, the updates are basically live for all the clients. Now I will hand it over to Hao to talk about the product perspective of why we are using SDUI.
Thank you, Philip, for walking us through some of the engineering considerations. So now I would like to walk you guys through some of the product experience we have that are driven by SDUI. So as you can see here on the screen, this is our homepage experience in the native iOS app. So a lot of the content are personalized. So Faire drives a lot of personalized content with the insights we gather from the users, like their store type, their shopping behavior, etc. So we have a number of carousels on the page, and we have a lot of dynamic slotting logic going on. For example, my team recently launched a holiday shop experience where we have a banner on the homepage. And based on a lot of user behavior, we're shifting the banner to different positions, and we're updating the content based on the user type. Because of that, it is not scalable to implement these dynamic logic on every single client apps that we support. So we centralized all of them to backend, and SDUI enabled that for us. Apart from personalization, seasonality is also a lever for Faire to capture user demand. So, for example, the two example on the left, they are the holiday experience that I was talking about. They are what we call hubs. So we launch occasional hubs for holidays, Thanksgivings, like Mother's Day, even like fall and summer vacation occasions. At the same time, we also have evergreen hubs like gifts, sales, etc. So we leverage SDUI for those because it's not just data that's dynamic. We also need dynamic layout. To pair with the SDUI system, my team also developed an algo-driven server. So if you look at the bigger picture, we have a thin client that's only responsible for interpreting the layout, and at the same time, we have a thin backend that is driven by a algorithm or data insights. On the right, we have a weekly drop feature, which is also highly leverages the dynamic nature of our content and recommendations. So we want to present curated products and lots of content for the user based on their behaviors. And this page also leverages SDUI entirely. So at Faire, our engineering and product teams, we are very data driven. So we launch a lot of experiments. So every single feature that we launch or updates we launch, we want to A/B test them to capture user insights and learnings as much as possible. Example here is recently we have an experiment launched where we updated some of the product recommendations, and at the same time we updated some of the content as well as imageries on the carousel. This carousel is on homepage as well. Because of how SDUI is already able to support all the customizations, this experiment basically required zero client change. And we were able to get all the analytics logging and capture all the insights for experiment analysis. A second example here would be adding carousels, removing banners, rearranging components on the page. These are requirements we get quite often from the product side. So SDUI allows everything to be controlled from the backend side. So example here, we have a team requesting 2 carousels to be added to the product details page. And because of how SDUI is able to provide that functionality out of the box, it requires zero client change, and we are able to get all these trackings correctly. So at Faire, for example, we track all the impressions properly. So as you scroll on a carousel, we track all the products that's visible and their viewport percentage, etc. And they are all available through the SDUI framework without any client change. Last thing I want to highlight is consistency across surfaces. So as you can see here, we have the same carousel called recently viewed, and it's being displayed on a couple of different surfaces, like category page, home page, and on the far right, it's the product details page. Usually when we want to make an update, we want to make sure this update is propagated to all the product surfaces, and SDUI gives us exactly that because every single surface, they're sharing the exact same implementation. In the past, we have seen a lot of occasions where like one of the carousel got missed during the process and it became inconsistent with the rest of the app. So SDUI provides us with that consistency in design and user experience. Hopefully at this point, I have convinced you guys why SDUI is a good fit. If not, feel free to reach out to me and Philip after the talk. So now let's take a look at how we built SDUI. For starters, let's look at the schema. We built SDUI, we developed a unified schema for into a 3-level layout. So on the very top layer, we have something called the view layout, which basically contains page level metadata. And then each layout can have a number of sections within it. And then each section is also carrying mostly information about how to lay out those components within the section. At the very bottom level, we have a component which is essentially the smallest unit in the system that represents a standalone UI element on the screen. Sections are a lot more complicated than the other two concepts. So as you can see here on the screenshot, we essentially have a page with two different layouts. On the very top, we have what we call a single column layout, which basically vertically stacks the components in a list, while the bottom half is actually something we call a filterable paginated section that has pre-built filtering logic as well as pagination logic. And each of these tiles in the list, they are still standalone components. So essentially, a good way to look at this structure is that sections and view layouts, they are responsible for handling metadata as well as page level action handlings, while components carry their own UI data. Now, let's take a look at the anatomy of our components. So I mentioned that the components are the smallest unit, but they're actually composed of something we call atomics. So example here is typography. So we got all the atomics from our internal design system to make sure every single thing in the SDY system is consistent with our design language. So as a first step, we codified all our design system into like backend and the schemas. So for example, on the right here, we have typographies codified in the SDY system. And the banner component on the left, they're essentially composed of a number of text elements as well as buttons and images. They are all consistent with our internal design system. So we don't have time for a deeper dive here, but this is exactly how the banner component is represented over the wire. So if we want to take a closer look, you can see that a title is essentially a text element, and with the pre-built token saying that it's a core, it's a header text with a semantic color token as well. That also means that in the future, or when we support dark mode or dynamic type, dynamic sizing of text, all these semantic token is going to help us to make sure we support the most accessible experience for our users. I think that's the end of the schema. So I'll pass it back to Philip to talk about more about the SDY system.
Okay, thank you, Hao. I want to highlight some of the implementation considerations that we have while building SDUI. We will start with the first of all actions. It's actually a big part of UX that we need to provide the correct feedback when user behave like some activities like scrolls or clicks. We have action fields on the section and the component level. Like on click and on view that instructs the client to perform specific actions. We support like a range of actions, some of which are shown here, allowing us to dynamically adjust behaviors as required. You may notice like our action field are actually lists, as we often need to trigger multiple like actions simultaneously, such as like when a button click is happening, we need to trigger both like navigating and also logging. Next slide. Another consideration would be like versioning. Is basically we need to make sure our system is like backward compatible. During migration, we gradually add support for like new components or sections. And also we are required to like running A/B tests just to make sure there's no performance regression or like UX regression. To manage this, we implement the API versioning to control the availability of a certain components. Each layout API is being assigned with like a version number based on basically the page it's originated from. We then cross-reference those API version with two lists. One is the allow list, which specifies the minimum supported version for each component. And we have a block list, which serves as a kill switch to basically disable certain components for specific version, just in case if there's bugs or issues are found for that version. If the API version is like below the minimum supported version from the allow list, or it's being specified by the block list, which basically displays the legacy UX. Our fellow Faire engineers standing there already mentioned previously on how important the performance are. So that's exactly why we keep it in mind while we are building SDUI. That way, like any page adopting SDUI can easily adopt those like performance improvements. The first performance improvements I want to highlight here is lazy loading. We build the vertical lazy loading. While loading a page, we only return the above the full content in full. Everything below the initial view are in skeleton. They get enriched once the user start to scroll down further. This will drastically reduce the first API's response size and also save time to calculate the full content. Here's a quick diagram on like how things goes. I won't go into details, but like the pending components are get loaded in a second API call, which typically triggered when users start to scroll down. Here's a quick demo in slow motion with intentionally slow down network, as like lazy loading will help user with like slow internet connection the most. We run experiment and it shows like we're able to speed up the loading speed by 12%. Another speed improvements I want to highlight here is the partnership with Next.js team on basically two pieces. One is the server-side rendering and also partial pre-rendering. On web, we use the Next.js server-side rendering under the hood to render SDUI pages with all the SDUI components written in React server components. We essentially basically let the React server to do the heavy lifting, which is obviously faster compared to the traditional browser rendering process. We also are looking in some more advanced feature from Next.js, like partial pre-rendering, which allow us to cache those like static components or a page template on the web server, then send it to the browser first once the user start browsing, so it could show up almost immediately. At the end, I want to highlight what I have accomplished so far. We have been successfully migrated 5 pages to SDUI. Those are pretty dynamic page with like personalized content. And also we are happy to announce that we were able to reduce our client-side complexity drastically. We removed 90% of our legacy renderers. We removed over half of our line of code from the client side code base, and also we increase our test coverage on client. The last is like we were able to get the faster runtime. With the help of SDUI, we can spin up a simple landing page within a week from like design to delivering to the user. I think that's end of our presentation. I will hand it back to Jeff.
Cool, thank you. Thanks, Philip. Yeah, I just wanted to, can you thank all the speakers? Like, thank you so much, Hamid Reza, Michael, Chris, Jordan, Alir, Hao, and Philip. If you want to give it up for the speakers tonight. Yeah, great job. I also want to thank the organizers. So big shout out to Amanda, Dev, and Angela. They're in the back there as well. Thank you for organizing tonight. It's been a great evening. And a special shout out to Leandre for all of the tech support and getting us set up with all of the notes tonight. So thanks so much. Thanks for attending. Thank you so much. We are here to mingle, chat. If you have any questions, you saw a lot of really cool technical content tonight. We're all here to answer more questions. So we'd love to have you stay and mingle. Please ask us questions, come up. Don't be shy. But thanks so much for coming tonight. Thanks.